Hi all, this is a video on the discriminant, which is actually a really useful part. It's linked to the quadratic equation, and it's a very useful thing that enables us to know how many roots a quadratic has without actually having to solve the equation. And sometimes that's just useful information to know. We can know what the shape looks like, we can know a whole lot of information without actually having to solve the equation. So the discriminant is given by, we use this little sign, this triangle, and it's given by that triangle equals b squared take 4ac. Now you might recognise that b squared take 4ac, you should, and where you recognise it from is from the quadratic formula. So using the discriminant, the quadratic formula becomes that x equals negative b plus or minus the square root of the discriminant all over 2a. If we calculate that value and that value is greater than 0, that means that there are two real distinct solutions. Or if you want to say that in another way, if I can fit it, there's two real roots. Remember, roots is a word for x-intercept. If the discriminant is equal to 0, that means that there is a repeated root. Okay, so there's one solution and a repeated root. We talked about, when we did the video on solving equations, how a repeated root is really a double root. So there's still two roots, but it actually just occurs at the same place. So there's one solution, and it's a real distinct solution, and it's a repeated root. And then finally, if the discriminant is less than 0, that means there are no real solutions. In fact, there are what we call imaginary solutions. But you don't really need to worry about that. All you need to know is that there's no real solutions, and that means there are no roots or no x-intercepts. So if we have a graph, the graph would look like that. So if we've got a question like that, use the discriminant to determine the nature of the roots. We can go, well, the discriminant equals b squared minus 4ac. So the b is going to be negative 2, so negative 2 squared minus 4 times 2 by 3, so it's going to be 4 minus 24, which is minus 20. So the discriminant here is less than 0, therefore there are no real roots, and there are actually two imaginary roots. Okay, that would be the answer for that question. Now we've got a bit of more of a curly question down here. If we consider this function, x squared take 2x plus m equals 0, we have an unknown there, but it says to find the discriminant and hence find the values of m for which the equation has all these three things. So we're just going to quickly do that. If we've got x squared take 2x plus m equals 0, we're first going to find the discriminant. B is negative 2, so it's going to be negative 2 squared, take 4 by 1, because the coefficient of x squared is really 1, by c, which is m. So it's going to be 4 minus 4m. That's going to be our discriminant. So for a repeated root, that implies that the discriminant equals 0. That's a good way of communicating that you know what you're talking about, rather than just putting down information. Just write a really quick thing that explains why you're doing what you're doing. So therefore, 4 take 4m equals 0. So negative 4m is equal to 0, equal to negative 4, and m is equal to 1. So when m equals 1, that's when we have a repeated root. Two real roots, and distinct is meaning it's not a repeated root, because this, as we said, has two roots, but one's just repeated. Two real distinct roots, that implies the discriminant is greater than 0, so we're going to go, well, when is 4 take 4m greater than 0? And that's when negative 4 is greater than negative 4. And then remember, if we're dividing by a negative, we reverse the inequality sign. So that is when m is less than 1, because we're doing negative 4 divided by negative 4, which is 1. So then m is less than 1. And then when there's no real roots, that will mean that the discriminant is going to be less than 0 when there's no real roots. So no real roots. And you just write that, no real roots. And so the discriminant is 4 take 4m. So when that's less than 0, negative 4m is less than negative 4, and therefore m is greater than 1. Now, how do I know that m is greater than 1? Well, I divided by negative 4 on both sides, and because I'm dividing by a negative, I have to reverse the inequality sign. So that's where that comes from. So just when you get this question, just have a think, does that make sense? And it does. I've got 1 happening, and I've got when it's less than 1. That means my discriminant is greater than 0, so I get 2 x-intercepts. And when my m, this is m down here, and when my discriminant is equal to 1, then I get I get a repeated solution. And when my discriminant is greater than 1, I get no real roots. Now I actually want to go through one more example, because some of the examples in the textbook are a bit woozies. So I'm going to go through the example that's actually from the textbook, because that actually help you when you get to the question and go, well, what on earth is going on? So we've got a very similar question. We need to find the values of m for which the equation 3x squared take 2mx plus 3 equals 0 has, and then we firstly have one solution, two solutions, and no solution. So let's do it when it's got one solution. Again, we're going to find the discriminant. In this case, b is actually negative 2m, so we get a negative 2m squared, take 4a, which is 3, by c, which is also 3. So we end up getting that the discriminant is 4m squared take 36. So far, so good. When we've got one solution, that means that 4m squared take 36 must equal 0. So 4m squared must equal 36. M squared must equal 9. And therefore m equals plus or minus 9. So far, so good. Or m equals plus or minus 3, sorry. Square root of 9 is 3, so m equals plus or minus 3. We drew out a really quick little sketch of what this graph actually looks like. So I'm just going to draw that out again for this one. I know now I've got two values. I've got negative 3 and 3. And I know that at those values I have no solutions. I have one solution at those values. So that's how far I've got so far. Now I want to do when I've got two solutions and two real solutions. So two real solutions, that's when my discriminant is going to be greater than 0. And so that means that 4m squared take 36 is going to be greater than 0. Now this is a little bit harder to work out, because if we rearrange it, we're going to get a little bit of funny rearrangement going on when we work with that inequality. So what we have to do is just have a look at our graph and fiddle with some figures. Have a look at this, and you'll do this a bit later, but it's called a sign diagram. We want to have a look at this sign diagram of the discriminant, and all we want to do is check different values. So let's check values that are less than negative 3 and see if they're positive or not. So say if m equals negative 4, then our discriminant would equal, and you can work this out, but it would equal 4 times 16 take 36, which is a positive value. So that would be positive over there. Now, if it's between negative 3 and 3, so say if it equals 1, so if m is 1, your discriminant would equal 4 take 36. It would be less than 0. So that means it's negative in there. And if m is equal to 4, say, then similarly the discriminant would be greater than 0. So it's positive over there. So just by doing that, we now know the sign of our discriminant. We know, therefore, two real solutions if when m is less than negative 3 or m is greater than 3, because that's when the discriminant is positive, and no real solutions, or no solutions if the discriminant, if m is between negative 3 and 3, because that's when the discriminant is negative. So when negative 3 is less than m, which is less than 3. So that is really helpful, and you'll only need to do that when your discriminant is a quadratic. So when the discriminant is a quadratic, so it's actually squared, then you'll need to actually do a sign diagram. Okay? So please write that in your booklet somewhere, so you can refer back to it when you're doing the questions. Hopefully that helps. Thanks, people, for